In almost every garden, a creature ignores the standard rules of aerodynamics. It hovers motionless in midair and then smoothly reverses backward. This maneuver is no optical illusion, and the bird is not simply reversing the direction of a normal wing beat. What we're actually seeing is a complex manipulation of physics, allowing this bird to execute a maneuver no other avian species can match. Most birds fly much like airplanes. They generate forward momentum by pushing down against the air during a heavy downstroke. The upstroke is mostly passive, repositioning the wing for the next push. Hummingbirds possess a skeletal exception. While standard birds have hinge-like wing joints, a hummingbird's shoulder acts more like a ball and socket, freely rotating nearly 180 degrees. Because of this flexibility, the wing never takes a passive break. The bird constantly manipulates the air, working through the entire range of motion. Without this specific joint structure, the aerodynamic control required to maneuver effortlessly in all directions would be physically impossible. To understand how a hummingbird flies backward, we first have to deconstruct how it hovers in place. A hovering hummingbird doesn't flap its wings vertically. Instead, the wings sweep horizontally, tracing a rapid, continuous figure-8 path through the air. By maintaining this continuous loop, the wing generates aerodynamic lift on both the forward stroke and the backward stroke. When that constant upward aerodynamic force precisely matches the downward pull of gravity, the bird achieves perfect suspension. Generating that constant force depends on the wing's angle of attack. At key moments during the stroke, the wing rapidly rotates. It acts as an active aerodynamic surface, continuously changing its orientation to control exactly how the air flows around it. As the wing slices and rotates, it causes the air to curl at the front edge, forming a distinct rotating structure of air known as a leading edge vortex. Flight is maintained by a precise interaction of wing motion, rapid wing rotation, and continuous fluid dynamics. These combined forces act as an invisible engine, supplying the raw lifting power needed to keep the bird suspended midair. With the bird suspended, we reach the mechanics of moving backward without changing the base figure-8 wing beat. The hummingbird alters its wing kinematics. It makes highly specific adjustments to the motion, the exact rotation angle, and the timing of each stroke. These adjustments tilt the aerodynamic force. A vertical force keeps the bird hovering, while tilting creates a forward push. By angling the wing differently, it redirects the net force toward the rear, pulling itself backwards while generating lift to fight gravity. As a result, the entire bird moves backward because it has successfully redirected the physical forces acting on its body. All of these physical adjustments happen at high speed. A hummingbird's wings beat anywhere from 50 to 80 times every single second. This pace requires the bird to execute microscopic, real-time adjustments to body orientation and stroke amplitude. The bird continuously senses its exact spatial position, correcting its wing kinematics on a beat-by-beat basis to maintain its flight path. This makes backward flight a dynamic aerodynamic maneuver, requiring constant corrections to maintain its balance in the air. It takes a significant amount of effort to fly this way, which raises the question of why this complicated method of movement evolved. The answer lies in their environment. Hummingbirds feed on nectar located deep inside delicate flowers, forcing them to navigate into tight spaces and then back out of them. Moving backwards provides precision maneuverability. The bird can feed and smoothly retreat without needing the physical space to turn its body around. Standard birds cannot replicate this, as their joints and muscles are optimized for efficient, long-distance forward flight. But there is a biological cost. This method of flight is so demanding that the bird must feed almost constantly just to sustain its energy levels. The ability to fly backward is a specific biological adaptation, engineered for survival in a highly specialized ecological niche. Watching a hummingbird pull smoothly backward away from a flower, you can see the results of millions of years of aerodynamic refinement. These tiny birds don't break the laws of physics. They have simply mastered them more completely than almost any other creature on Earth. Nature is filled with physical secrets waiting to be decoded. To continue exploring the science behind the natural world, please like, share, and subscribe to Fusion IQ.